So jovial.
Callisto and Ganymede are not on
Doesn't fit.
there? Callisto and Ganymede? I see Io and Europa.
Yeah, they're outside the crystal.
Okay.
Well, if you tried to get all the moons in there, you'd need about 2 meters, I think. Yeah. So now we're out at Jupiter, and I think, you know, one of the great things to do just right out here is just to look back. And in particular, depending on where you're standing, if you can see the sun, you know, you're seeing what its angular size would be from Jupiter. And so you can see it's gotten small. It's going to be pretty dim compared to what it is at Earth when we're out here. Jupiter, of course, it's a system, right? It's got 4 big moons, but dozens of smaller moons. The 4, Io, Europa, Ganymede, and Callisto, are all big enough to be seen on this scale, but only Io and Europa fit inside the crystal. Couldn't get the others in there because they're further out. One other thing that's kind of important to notice here, particularly for those of you who are teaching, is people tend to be a little shocked to see the rings like this around Jupiter. It does have rings. They're not as prominent as this makes it look, although the new James Webb infrared photo of Jupiter does kind of look like this. And so in case anybody's ever wondering why are the rings so prominent in here, it's because with these laser crystals, basically that's the thinnest you can make them, or you can't have them at all. It's just a limitation of the laser crystal technology, and we thought it was more important to have them there to emphasize that these outer planets all have rings than to have them not be there. And you can see the ring there in the photo, a little more realistic of the way it appears. And of course the volcano on Jupiter, on Io. Europa, of a particular interest because of its subsurface ocean, place where if you're betting on where we'll find life in the solar system, that's probably one of the best bets. Smaller possibility for Ganymede and Callisto. They also seem to have subsurface oceans, but probably less energy available for life. But we're going to learn a lot more because there's a mission, a European mission to Jupiter to study Europa, Ganymede, and Callisto called JUICE that's launching in April. So like a month from now, JUICE mission should be launching. Unfortunately, it's one of those complicated gravitational paths to get there because they couldn't afford a bigger rocket to get it there quick, right? So it'll take six years, I think, to arrive. So it'll be a while before we get any actual data from it, but it's going. So we've got another mission heading off to Jupiter now. And the other really important thing to notice here is that's a planet, right? It's not a dot like the other ones that we saw, right? You remember the show Third Rock from the Sun. I mean, that's kind of accurate. Earth's basically a little rock in the solar system. This is a real bona fide planet here. You know, we kicked Pluto out of the club a few years ago, but imagine that if people who lived on Jupiter, they probably would have kicked all the 4 inner planets out of the club, right? There's only 4 planets in the solar system if you ask the Jupiterians. So where that cutoff comes is an interesting question. All right, now we got a long walk to Saturn.